Alright, so let's take a look. We need to look at this pink half sheet. We are starting our last and final unit in 7th grade. At the end of this unit, we should end this unit sometime right before spring break. I have us finish unit 2, taking the test 2 days before spring break. After spring break, we'll get 2 weeks of review before Georgia Milestones. And then after Georgia Milestones, we'll work on tasks and some higher order thinking skills before we get ready for 8th grade. All right, let's take a look at the unit overview. So this kind of builds on our statistics unit that we just finished. We did a little bit of probability. We did some prediction and probability. So we're going to focus in this unit on just on probability. Probability is a likelihood that something will happen. So if my children bring home an F from school, what's the probability that I am going to be mad? 100%. Okay, so we're just going to look at probabilities, but we're going to think about probabilities. If we look up on the board over there where it says 7th grade, what's the probability, or what is probability, and what is the likeliness of an event occurring based on a probability of 0, a half, or 1 whole. So we didn't say 100%, but how does that relate to 100%, that 1 whole? Half is 50%. 1 whole would be 100%. If I have a whole cake, I have what percent of the cake? 100%. So we have to think about, we're going to talk about probability as 0. So is something going to happen if I would say the probability is 0? No. What if I said that the probability is half? Do you think it's going to happen? Maybe. 50-50. Might happen. It might not happen. And if we said that the probability was a 1, what do you think? It's definitely going to happen. It definitely happens. Okay? All right, so let's look. In this unit, students will understand probabilities are fractions derived from modeling real-world experiments and simulations of chance. So we can talk about things that happen in the real world, or we can set up experiments to make a prediction. Modeling real-world experiments through trials and simulations are used to predict the probability of a given event. So they use simulations, or maybe picking a card or drawing something out of a bag. Those are simulations. That's like predicting the weather. They use simulations to predict the weather. Did you know that? So they create different things that are happening in the computer, and if this warm front comes down and this cold front comes up and they meet, if that's a simulation, if those two things happen, then you're going to have a storm. So that's why sometimes the news predicts something and then it doesn't always happen, because the weather changes course or something like that. Chance has no memory. So whatever just happened, so say I had red marbles, blue marbles, and yellow marbles in a bag. If I pull a marble out and it's blue, there is no memory of what just happened. There's nothing that means the next one's going to be a blue. So whatever happened in the previous drawing does not affect the next one. That's what that no memory means. The probability of a given event can be represented as a fraction between 0 and 1. A probability of 0 means an outcome has 0% chance of happening, and a probability of 1 means that the outcome has a 100% chance of happening. A probability of 50% means an even chance of the outcome occurring. The sum of the probabilities of every outcome in a sample should always equal 100, or equal 1, which is 100%. The experimental probability or relative frequency of outcomes of an event can be used to estimate the exact probability of an event. Experimental probability approaches theoretical probability when the number of trials is large. So that means that you need to perform an experiment several times to be able to make an accurate prediction. If you just pull one marble out of the bag and it's blue, that does not mean that every time there's a 100% chance that you're going to pull a blue one out. Let's see. Sometimes the outcome of one event does not affect the outcome of another event. This is when the outcomes are called independent. Tree diagrams and arrays are useful for describing relatively small sample spaces and computing probabilities. We're going to learn how to make a tree diagram and some arrays. And simulations can be used to collect data and estimate probabilities for real situations that are sufficiently complex that the theoretical probabilities are not obvious. Okay, so this unit is a lot different than what we've done earlier in the year. You have to do a lot more thinking about what might happen. So we'll spend a few weeks working on it and actually doing some experiments to see how it works. Okay. All right, so this is going to go in our journal on I have page 129. So we're going to start this unit in our journal on page 129, and we'll glue that there. All right, so if we turn the page, we're on page 131. And at the top, we're going to write probability. And we're talking about outcomes out of 1 or 100%. We need to know those are the same thing. And then I want you to take this orange sheet and you're going to cut all of these apart. Put the fractions together, the decimals together, and then we're going to organize these on our page. So go ahead and cut them out. All right, so you're going to need to turn your journal sideways, and you're going to draw a straight line right here. And we're going to create a number line of sorts. Starting down here with 0. 0% chance of anything happening. And down here on this end is going to be a 1, which is 100%. So you turn it sideways. You're going to 0 and 1. Halfway is going to be what? So about a 50% chance. We're not going to put anything right there. So then halfway between 0 and 50% is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5. There's about halfway. So I'm going to use my decimals. So if there's 0 there, 25 hundredths goes there. Then what? Five tenths or 50 hundredths. This is just not. Let's see. Yes, maybe. And this one is the 75 hundredths. So 0, 25 hundredths, 50 hundredths, or 5 tenths, 75 hundredths, and 1. So you can glue those into place. And then next we want to look at our percents, all the percents, and decide where they go. You should have 5 of them. What percent goes with 0? 0%. 25 hundredths, what goes with that? And I want to put it down here. I want to leave space because I want to put all the percents together. The next is 25%. What comes after 25%? 50%. Next is 75%. And the last one is 100%. So do you see how all of these things relate to each other? When we're talking about probability, we can talk about 0 and 1. We can talk about the decimal. We can talk about percents. Those are all different ways to talk about probability. Next, I want to look at these words. I want to look at likely, impossible, certain, even chance, and unlikely. I want to decide where we think those go. There's 5 of them, and there's 5 different categories that we have here. So, looking at those 5 words, I want you to find your 5 words that look like that. Unlikely, likely, even chance, impossible, and certain. And I want you to make some decisions about where you think they go. Go ahead and scoot them into place where you think they go, and I'll come around and I'll look. And then you can glue them. All right, so let's see. Possible. So now we should have our words that go with our probability. 0 is impossible, 25 hundredths is unlikely, 50% is even chance, 75 hundredths is likely, and 1 or 100% is certain. Yes? Did I not do it right? Oh, it doesn't matter where you put it. I'm just afraid I'm going to run out of room. So if you put it down here, that's okay too. All right. Now we've got some fractions. We've got 3 fractions. We have 1/4, 1/2, and 1/4. So where do these go? Where does 1/4 go? Right. So 1/4, 1/2, and 3/4. Where's 1/4 go? Right here at 25 hundredths. 1/2 goes at 50, and 3/4 goes at, yeah. Why don't we have a fraction for 0? Because it's 0. Why don't we have a fraction at 1? It's 4/4, and that is equivalent to 1 whole. So if I wanted, I could write a 0 here. And here I could write 4/4, if that made me feel better. It might. I'm not sure. So we'll glue those into place, and then we're just going to look at the different situations we have and try to determine the probability. So, with these different situations, some of them may be personal to you and some of them are just generic. So let's look. Let's start with what we think about this one. At least one student will be absent tomorrow. Based on what happens in this room, what do you think the probability is that at least one student will be absent tomorrow?
75%.
I'm not sure we could say 100% because but probably 75%. We've had a couple of days when everyone's been here, but for the most part, someone is usually absent. So I would glue that one under it's likely that one student, at least one student, will be absent. All right. Let's look at, it will rain tomorrow. It will rain tomorrow. Anybody watch the forecast?
No.
What do you think, Danielle? It's most likely going to rain tomorrow based on the forecast. If we hadn't watched the news, it might be more of a even chance. If it was summertime and we were in the middle of a drought, it would probably be unlikely. This one would be very fluid based on what is happening. But because I know what the forecast says, I probably would put it at likely. All right. Here's a good one. You will meet President George Washington on the way home from school. What do you think? Impossible. He is passed away a long time ago. He is no longer on this earth. So we will put it in impossible. All right. How about this one? The sun will rise tomorrow morning. Certain. If it doesn't, we are in big trouble. So, certain. All right. The Braves will win the World Series. I don't know how they're playing. I don't understand.
I don't know baseball.
I have not been following. Are they good this year?
Yes, they're very good.
They are?
You don't watch spring training? It's even chance.
No. Okay. I'm going to put it under even chance because I don't know. Yours might go somewhere else based on the knowledge that you have, but I'm going to put mine under even chance. All right, so this one is going to be your own choice because it has to do with you. You will watch TV sometime today. I've already watched TV. I watched the news while I got ready this morning. So I would put mine under certain because it's already happened. If you rarely watch TV, it might be over here under unlikely. If you don't have a TV at your house, it would be in impossible. So put yours where you think it goes. Mine's going to go with certain. All right. If today is Friday, tomorrow will be Saturday. If today's Friday, will tomorrow be Saturday?
Absolutely, if today gets to be Friday.
If today is Friday, then yes, the next day is Saturday. That is certain. It's got to go under 100%. I've never had a Friday where the next day is not Saturday. And I've been alive a while. It's not funny. I'm a grown-up. I've been alive a while. Not a million years, but a few years. All right. Oh, this one again might be a personal choice.
Nope, zero.
You will be in 8th grade next year. There's some of you that that's certain. There's some of you that it might be unlikely. There's some of you there's a 50-50 chance.
Impossible.
I don't think that that's impossible for any of you. I would think for most of you it should go under certain. Where would it be for me?
Unlikely. Impossible.
Impossible.
They know you have to
pass.
Mine's going to be an impossible.
Hey, maybe not. You might have to teach it.
They might kick you up to 8.
All right. Next. If you drop a rock in water, it will sink.
Likely.
No.
It depends on if it's heavy or not.
We've determined in previous classes, we determined there was one kind of rock. I forget what the name was. It's factual evidence. So most likely it will sink. So I would say likely or certain, but I did have some people that knew a lot about rocks. I'm going to put mine under certain because anytime I've ever thrown a rock in water, it will sink.
What if it's a fake rock?
Big rocks.
Again. It's your choice where you put it. All right, this was your personal choice. You will go to the beach sometime. I'm going to put it under certain because I already have reservations for the beach this summer. So I'm putting mine there. If you've never been but want to go, you might put it under unlikely or even chance. Mine is going to go right there. All right. It will snow this week.
Already did.
It already did snow this week. It did at my house.
Don't call that
About
snow.
your house. Or was that last week? And Monday started a new week. I don't know.
Oh, Sunday starts the week.
And
It snowed Saturday.
it snowed Saturday. That was last week.
But it snowed
But the
Sunday
snow was
night.
still there Sunday.
Sunday morning.
But it
It snowed
didn't
Sunday
snow.
morning.
So I might put mine under likely.
Impossible.
I don't know that it's impossible that it would snow this week. It might be unlikely that it's going to snow again. What do we think? I'm going to put it under unlikely. I don't think it's going to snow anymore.
It is. I'll go and buy a snow machine.
Yeah,
That's $100.
Just so you'll be.
All right, last one. You will have 2 birthdays this year.
Absolutely.
Yeah, Christmas.
Impossible.
What?
Not birthday celebrations, but 2 actual days that are your birthday. That is impossible.
No, that's not supposed to be.
Oh, your half
Forgot to
birthday.
put the time up.
Half
Oh, to change the time? Yeah. All right. So do you have a better understanding of how you can talk about probability? Yes, you should. All right, so we need to go back and we need to do our table of contents. Let's see. Oh, we're starting a new unit. Let's see what color I want to use. I'll use blue again. So we are on Unit 6. And let's see. 129 was the Unit 6 overview. All right, let's take a look at the skills practice. Probability of simple events. So we're going to use what we just were discussing in our journal, and see how we can use probability to talk about simple events. So, a card is randomly chosen. These are the cards. Find each probability. Write each answer as a fraction, a decimal, and a percent. So the first thing is let's write it as a fraction. So this capital P means what is the probability that if these cards were all turned over, that the card you choose is going to be a B. What is the probability the card will be a B? So how many B's are there?
One.
One. So 1 out of how many cards? 1, 2, 3, 4, 5, 6, 7, 8. 1/8. That's our fraction. Now we've known since 6th grade how to turn that fraction into a decimal. How do I turn a fraction into a decimal? What's the math we do? Divide. 1 divided by 8 is 1 divided by 8. 125 thousandths. And so, what is that as a percent? No, move that 2 places to the right, and it becomes 12.5%. So is it likely that you are going to choose a B?
No.
No, I could have already told that. There's only 1 out of 8. That's unlikely that you would choose that. All right, the next one. What is the probability that you will randomly choose a Q or an R? How many Q's or R's are there?
2.
There's a Q and an R. So there's 2 cards that are Q's and R's. So 2 out of 8 as a decimal. I think that's going to be 25 hundredths. And as a percent, that is 25%. All right. Number 3. What is the probability that the card you choose will be a vowel? How many vowels are up there? A, O, and E. 3/8. 3/8. 375 thousandths. And so the percent is 37.5%. So halfway between 37% and 38%. Everyone good so far? All right, number 4. What is the probability that you will choose a consonant or a vowel?
Oh, no.
Consonants are letters that aren't vowels. When you take the vowels out, everything left are consonants. So 8 out of 8. It's the whole number 1. And so as a percent, that is 100%.
Don't worry. Constant is it's not a vowel. I know.
All right, number 5. What is the probability that you will choose a consonant or an A? So that's the only one that leaves out is O and E. We're talking about all the rest of them. So if we take out the O and E, 6 out of 8. 75 hundredths. And that is 75%. Good so far? All right, the last one. What is the probability of choosing a T?
0.
0. So 0. Do I need to go any further? No, just 0. Can't happen. Impossible. All right, now we're going to look at a different simple event. This was a simple event of drawing a card. This is a simple event of just spinning a spinner. The spinner shown is spun once. So you're just taking it and spinning it once. Write a sentence explaining how likely it is for each event to occur. All right, so what is well, the words like we were just using. What is the probability that you will spin and land on a dog?
3, 6.
3 out of 6. So is that writing a sentence or is that writing a fraction? That's writing a fraction. So think about it. Is it impossible, unlikely, likely, probable? Okay, so there's 1, 2, 3, 4, 5, 6. 3 out of 6. So there is an even chance. All right. What is the probability you will spin and land on a hamster? So that would be probably not likely or unlikely. All right, so you get the idea for this section, right? Okay. Now let's talk about these two down here at the bottom. They're a little more difficult. The weather report says that there is a 12% chance that it will be moderately windy tomorrow. So is it really likely it's going to be windy tomorrow? No, 12%, not a lot. What is the probability that it will not be windy?
88.
How did you get that? Yes. You have to take 100%. There's a 100% chance something's going to happen tomorrow. When you take the 12% off, that leaves 88% chance that it will not be windy. Do you all know why we started with 100%?
Because there's 100
Yes, something's got to happen. When we take that 12% off, that leaves 88% left. Will tomorrow be a good day to fly a kite? So predict, will it be a good day? No, because it probably will not be windy.
Is a hamster a mammal?
Yes, it is.
Is a dog a mammal?
Yes.
Is a cat a mammal?
Yes. Okay. All right. This does seem easy, but again, we're talking about probability of simple events. Later, we're going to have compound events where it's going to get a little more difficult. So this should seem relatively easy. I want you to finish this side. So that leaves you 3 problems on this side. And then you need to do the homework practice for homework tonight.